Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay, again, okay, we still in exercise 3. Okay, for our last question, okay, which is question 7. Okay, so if you refer, okay, to the circuit, it's given in figure. Okay, the series parallel circuits. Okay, so the 30 ohms resistor absorb an average power of 700. Okay, 750 watts. Okay, so the resistance of 30 ohms. Okay, so which is attached, the resistance is attached in the first branch. Okay, okay, in series with the minus J10 ohms capacitance. Okay, so this resistance absorb an average or the active power of 750 watt. Okay, so determine the branch and supply current in phasor form. Okay, so all branch currents and also the supply currents. Okay, and then find the branch and supply voltages in phasor form. Okay, and then find the phase angle between supply voltage and supply current. Then the apparent powers for each branch in phasor form, the total active reactive apparent power and power factor of the circuits, and finally sketch the overall triangle with the aid of appropriate diagram and levels. Okay, so now we look on the solutions. Okay, so for the first questions, okay, it said that the 30 ohm resistor absorbs an average power of 750 volt. 50 watt. Okay, and then okay, we have two branches here, right? Okay, the first branch and the second branch. Okay, so the branch and supply voltage. Okay, so in first, okay, with the information of the average power, okay, 750, okay, which accumulated or which equivalent to P1, okay, branch 1, which also equivalent to the P is equivalent to I1 squared times R. Okay, so from here you can find the magnitude of I1. Sorry, please correct here. Okay, the I1, not I2, which equivalent to 750 divided by 30. Okay, 750 watt divided by 30 ohm resistor. Okay, so you get the I squared equivalent to 25. So the I1 is equivalent to 5 ampere. Okay, so by applying the formula beside here, okay, the magnitude of V, okay, is equivalent to square root of VR squared plus VC squared. Okay, we know that VR is equal to IR and VC is equal to IXC. Right? So the V is equivalent to I in bracket R time plus with XC, because the first branch here we have the resistor and the capacitor. Okay, so this magnitude you will get the V1 magnitude voltage. Okay, thus you can get the angle of the voltage. Okay, so by this voltage triangle formula, okay, so the phi or the theta here is equivalent to the inverse tangent VC divided by VR. Okay, so we refer back, okay, to our questions. Okay, so we have the VR, okay, is equal to 30 times 5, okay, which equivalent to 150 volt. Okay, and then we also, okay, have the VC, which equivalent to 5 times 10, okay, is equivalent to 50. Okay, and then the V1, okay, is equivalent to square root of 150 squared plus 50 squared, which give you the answer of 158 volt. Okay, about the theta or the angle for this voltage, okay, we get from VC divided by VR, which give you the angle is 18.43 degree. So the magnitude and the angle of for your V1 is equivalent to 158 with minus 18.43 degree volt. Okay, so if you refer to your circuit, okay, in the question given, okay, so the V1 is equivalent to V2 since they are in parallel connected. Okay, so V1 is equivalent to V2, which is equal to 158, okay, with minus 18.43 degree volt, because the angle are in negative portion. Okay, so the I1 here, okay, is V1 divided by Z1. Okay, so V1 is 158 with minus 18.43 degree divided by 30 minus T10, which give you 5 with 0 degree ampere. So that is your I1. Okay, so the next branch current is I2. So I2, okay, is V2 divided by 60 plus T20. So we know that your V2 is equivalent to your V1. So straight away, okay, we use the V1 values. Okay, so the V1, okay, is 158 with minus 18.43 degree, and the Z2 is 60 plus J20, which give you the I2 value is 2.5 with minus 36.83 degree ampere. Okay, and the last current is I total, which is the summation of I1 plus I2. Okay, so I1, okay, we found I1 is at 5 ampere with 0 degree, and I2 just now is 2.5 with minus 36.83 degree angle. Okay, so the total of these two currents give you 7.16 with minus 12.09 degree ampere. So that is the total current. Alright, so for the branch and the supply voltages in polar form now, okay, so the V1, okay, we found V1 is at 158 with minus 18.43 degree volt. Okay, and the V1 is equivalent to V2 since they are in parallel. Okay, so the V2 is also 158 with minus 18.43 degree angle volt.